Good morning, everyone. You lucky, lucky, lucky people. You've got me on track 1 this year. How are you? Is everyone all right? Yep. Come on. Excellent. Right. Your next speaker is Lorna Mitchell, who is a good friend of mine. Lorna is from Huddersfield and developer for IBM. Or developer advocate? Developer advocate. Okay. From Huddersfield. She's the author of the O'Reilly book, PHP Web Services. And interesting fact that she actually studied at York University, so this is home ground for her. Please give a really, really warm welcome for Lorna.
Well, thank you very much. Good morning, good morning. Last year we did this on the old campus, which was there when I was at university, so I had the experience of being on the stage of a room where I had sat in the back and fallen asleep on people for many years. So this year's a little bit less intimidating because I don't have those memories of this lovely new venue that we're using this year. Today I'm going to talk about databases. I think we're craftspeople. We work so hard at mastering the code, but the code that's in your repository isn't all that useful when it's not powered by the data that makes your application what it is. Being expert in databases, having good knowledge of those disciplines, is kind of out of fashion. But in truth, it will make a big difference to the work that you do. So I've tried to pick some databases that, statistically speaking, a PHP audience may not be familiar with. And just want to share my ideas. You know, PHP devs, PHP has had a long-standing, almost monogamous relationship with MySQL. It's typically our first choice. But there are lots of other options out there, and I'm not here to diss MySQL at all. It's something that I myself have used for more years than I'm going to admit. I feel safe saying the thing about, oh, this campus wasn't here, it's only been here 7 years. So maybe I only left uni 7 years ago, that could be true. But I've been doing MySQL for more years than I am prepared to admit. The job that I do now is, as Katie says, I'm a developer advocate with IBM. I am specialist in the open source databases available on IBM Cloud, and I've picked 3 of my favourites that I think are a really good fit for PHP, and I'm to share with you today. So if you are a bit tired, if you got up too early like me, you sort of drop off in the middle, don't worry, this talk's like 3 little talks about different databases, so just like drift off for a bit, tune back in for the next section. You won't be completely lost. The databases I've picked, PostgreSQL, which is very similar to MySQL. It would occupy the same space in your stack. Redis, an in-memory key-value store. And CouchDB, which is one of the document databases. So I'm definitely showing my favourites. I shouldn't have favourites. I'm responsible for lots of databases. But yeah, I can let you know these are my favourites. So let's start with Postgres. Postgres is a relational database. They're not really cool and trendy these days, but honestly, if you have data that you need to relate to other data, you will find a relational database does the job alarmingly well. Postgres is ideal for things that join, so orders with order items, with costs, with delivery information, billing information. We need to relate all of that together to make a whole order data. If you need to do any sort of aggregate functions, adding up monthly sales totals and that kind of thing, probably also a good choice. Things you should know about Postgres, there's the link if you want to go to their official homepage. It is an open source project. MySQL is an open source project. You can't buy Postgres. It's genuine, it's not controlled by anybody. It's genuinely still run by volunteers who build the stuff they believe in or the stuff that scratches their itch. There is no commercial drive. So if something could be said to be more open source than something else, Postgres is more open source. It performs very well. It's very familiar to you if you have MySQL experience. It works just as well with PHP as MySQL does. Most of the out-of-the-box frameworks or tools that we install with PHP, the majority of them will support Postgres just as easily as MySQL. If not, please patch it because they should, and it's not hard. Some of my favourite features about Postgres that I had picked for this talk actually will be available in the next MySQL release. MySQL 8 isn't out yet, but I'm keeping them in under Postgres because you're probably MySQL users, so you'll want to use these features too. So there's some stuff here which is currently Postgres, but is coming in MySQL as they catch up on some of those features. Now, when I was a MySQL-only user, I thought I knew a few things about Postgres. I had some preconceptions about Postgres. For example, I thought it was probably very powerful for complicated things, but very powerful for the big things, but probably a bit overkill for the simple stuff. Wrong. They're the same. They're really a very similar experience. They're both pretty friendly. The tools are great. If you like PHPMyAdmin, there's one for Postgres. There's no difference. And it performs perfectly well at low volumes as well. I also thought I would struggle with Postgres because I know that MySQL isn't very standards compliant and that I would be struggling with the strict syntax. This one's true, it's a feature. Standards are there for a reason. Hey, let's be more standards compliant. Let's make our skills more transferable. This is true and it's good. There are a few things that will trip you up in the syntax where MySQL is just a bit sloppy. And once you know the standard syntax, you can take that anywhere. I thought that Postgres would also perform less well on the simple stuff. Nah. Postgres is basically better at everything. Some of the new MySQL 8 benchmarks, if you set them up in a special way, show better. But for the kind of heavy lifting we do with our relational databases, it's hard to make the argument in favour of MySQL, in my opinion. Dave's not in my talk. Okay, good. Performance numbers, these are a little bit out of date, but it doesn't seem like there are newer numbers around. And I didn't have time to run the benchmarks myself. What you are looking at is a graph of how long it takes to do a variety of tasks. So smaller is better, meaning it took less time. We've got MariaDB as the light blue line on the top, MySQL is the dark one in the middle, and Postgres is the green one. It is faster at basically everything. They're about 18 months old, but then they're still stable versions and they're the most common versions. So I think this is still pretty valid. Feel free to run new benchmarks and let me use your figures, that'd be great. Postgres has different data types. It has more data types that it is specialist in understanding. I've picked a couple of my favourites. I give a whole talk about Postgres data types. Let's try and avoid me doing that right now. My favourites are particularly UUID, because I think it has a really wide application, and also the JSON fields. MySQL has some JSON support, but Postgres has more. There are a bunch of other things that I don't want to get too bogged down in. We have better date time stuff in Postgres. For example, we have an actual column type for an interval of time. So if you need to do any sort of date maths or duration maths, it's brilliant. And we have stuff like IP address. Just sometimes those things are handy. So as an example, looking at the UUID. So UUID, universally unique identifier. You can use this as your primary key and not have collisions even on a sharded database or across multiple tables. Almost definitely, probably. This is available by default on Postgres. Sometimes you need to enable the extension, but it should be there. Have a look at this create table statement. Look at the default on that primary key. We're calling a function for our default value. Postgres has this all over. You can call functions in all sorts of places. You're about to see it for indexes as well. I just think it's killer function. Now look at the insert statement. I'm going to insert into a table. Now, MySQL has spoiled you. That set, this equals that thing, not valid. It's not standard. I agree it's nicer and easier to maintain. This is standard. So you're going to insert into table, column list, keyword values, field list, right? And then put your actual values in that list. Just hold the thought on the returning keyword. When I run this insert statement, I give the product name jumper, and it generates that UUID for me, and there are different UUID versions, there's lots of different options. It generates me a unique identifier that I can use. That returning keyword will return me the UUID that was generated. There is no need for a last insert ID call, and you can use this. It's really useful for this, to know what primary key it was given. It's also useful for any kind of calculated or generated fields, if there's like triggers that run on insert or anything like that. You can use the returning stuff, and you can have a comma-separated value list of fields. So if it's like, insert this and then give me back those other fields that you just wrote because it's got an ID, a timestamp, and a running total of, I don't know, sales for that, then you can get all of that back from the insert or the update statement with the returning keyword. I love this in Postgres. The JSON types also are amazing. Sometimes you might be storing a whole load of JSON in a column. For example, I use it when I've got incoming webhook data. I just write the whole thing to the table so that I've got it and then I can process it later. It's also useful for situations where, a bit like the document databases that I'm going to talk about later, the data can be different. We sort of have this JSON blob and they can all be different. They can all look different from each other. The JSON fields come into their own. So if I alter my products table and add a column called attributes, because I had some problems fitting everything on the slide, to hold the attributes, and the column type is JSONB, and then I insert some data, right? So again, we're inserting to a table with a list of columns and the values keyword. I'm just inserting a JSON string as that second value. And you sort of think, yeah, okay, so what am I going to do with that JSON string? Should I actually extract the columns I want to search on? Well, you can, but Postgres can index on deeply nested data in a JSON column. It can search on those. You can use these things in your criteria. Either when you're in the select list or in the where clause. You can see both in this example. So the double arrow means, please dig in my JSON data for this. And it'll understand that and resolve it for you. Kind of magic. Okay, let's talk about indexes. Indexes are a key skill. Regardless of which relational database you are using, you should know how to use the explain plan and understand the indexes and how they affect your performance. Be careful with indexes. I once dropped an index on a system with some performance issues and caused a query taking 4 minutes to take 12 seconds by removing an index. So you need to know, like, don't just throw them out and hope for the best. You need to understand why you're adding those indexes and which things it's going to help with. They can be amazing. We use primary keys for uniqueness and also for very fast lookup. You can have indexes that add that fast lookup to another column or multiple other columns. Postgres can use more than one index in a query, which is nice. If you have what's called a covering index, the index holds all the data that your query is going to retrieve. So we only hit the index, which is faster access, than hitting the table. Covering index. Magic dust for very small queries. Postgres supports indexes that use expressions. So you can run a function and store the output of that for each row as an index. Example coming up. Primary keys, always unique. You can use the serial data type to get that integer auto-increment thing that we tend to do in MySQL. But let's have a look at that expressions example. I've got my employees table, classic example. The employees have an ID, it's serial, primary key. We've got a name, text. How interesting. We create an index on the name column, but instead of indexing the name, we're indexing strut lower name, right? It's case insensitive name. So instead of having to, so when you do your query, as long as you cast to lowercase, then we're case-insensitive searching very easily. This is just a simple example of the kind of stuff that you can store computed values in an index so that you don't have to compute for every row. This can be incredible. And it's a great example of where Postgres supports functions in all kinds of places. All right, two of my favorite Postgres features, both of them are coming in MySQL 8. So don't blank on me because you don't use Postgres. Right, these are coming. Common table expressions. This is syntactic sugar. You're going to tell me there's nothing here that you can't do in MySQL. And you're right, and yet I love it. It's a way of making your queries more readable by moving part of them into sort of a separate space and giving them a nickname. This is especially valuable if you have complicated and repeated subqueries. We've all worked on those systems that have a customer with an account, with a location, with a specific user, with a specific set of permissions, and it's joined in 3 places when you're retrieving some content, right? If you've worked with the EAV stuff, you're writing the same joins all the time. This is like a temporary view for the duration of this query. So the example here, the code example at the bottom is just a template. Use the with keyword, give it a nickname. The as keyword, write your subselect. Let's try and look at it with a real example. So I've got this data structure, I've got a products table. Each product is associated with 1 or more costs, and those vary by country, and they also have currency attached. So for each cost, there's the cost in this country, that country, the other country, and what units that cost is in. It's joined on so we can do a currency lookup. This gets messy, so we use the common table expression to make it easier. The query itself is the last 2 lines of this example. All that messy join malarkey, we just tidy it up into a CTE and use that costs in our main query. It's very, very neat. It's also easier to test because you can test your standalone subquery, see what it outputs, and then join it into your bigger query. Very, very neat. My second, this is my favourite. No, this one's my favourite. Window functions. If you use Postgres or your relational database for any kind of reporting, this is magic. So in other relational databases, and I am particularly thinking of MySQL, you can return rows with numbers in, or you can sort of roll them up and get the subtotals. This allows you to do both. You can get every row and the subtotals. How about subtotals by month, subtotals by quarter, and subtotals by year in a single query? That's because the window function means we can perform the aggregate function on any range of rows. We call it a window because sometimes it slides, sometimes it's this block, this block, this block. So we can do, current sales running total for the last 12 months. Do it. The syntax looks like this. We do count star, which you've seen before, but instead of doing it with the group by, we use this over and say how we would like to partition our rows. So in this case, I'm showing you every order. This is a rubbish model because every order has a single product ID in it, but it does make the example fit on the screen. So every order is for a single product. This is so simple you can understand it. And you can see all of the products, and this is an incomplete result set, but how many of this product were ordered. So you see we've ordered 3 hats, there are 3 in total. There are 6 t-shirts, not all of them shown here. So the window functions lets us do different groupings of aggregation in a single query, and the performance is better than you'd think. Magic. Okay, so things you need to know about Postgres before I move on. The PHPMyAdmin equivalent is called PGAdmin. It's not as pretty as new PHPMyAdmin, but I'm sure they'd love some patches. It has the best in-shell help I have ever seen. Type /h and then the thing you're sort of thinking of, and you get the documentation in there. For those of us who work mostly on the road, at the airport and in other silly situations, this is super helpful. The JSON features are out of this world. It's everything you can think of and a bunch of things that would never have occurred to me. So that's pretty cool. Being able to use functions everywhere, amazing, but in indexes, that opens some doors that I hadn't thought of before. You can choose if aces are high or low, nulls are high or low, with this addition to your query to say whether you want them on the beginning or not. If you're sorting ascending and null isn't relevant data, you can move them to the end. That's pretty helpful. Postgres is famous for having excellent geo support. So the PostGIS plugin is just, if you need to work with any kind of geography, this is where it is at. And there's a bunch of other plugins. You can get plugins for time series data and for more document databasey type stuff. Really incredible stuff. You can get a hosted version from IBM Cloud. We have a free tier, so you can play with some of that stuff. That was Postgres. I'm making the assumption that you were all familiar with relational databases. Let's talk about something new. This is Redis. Redis isn't something where you have to make the decision to switch out the database that you're already using. Redis is something that if you don't already have it in your stack, you might want to add it, like on Monday. It will solve a bunch of specifically web problems for you. Redis, the acronym stands for Remote Dictionary Service. It's a place where you go to look things up. It is open source. It's an in-memory key value store. Listen, it's in memory, which means it is blisteringly fast, and it can hold as much data as RAM you have given it. As RAM, you don't need anything else on the server to be using, right? You're not going to store massive data in Redis, because bad things will happen. Really, really bad things. But for a lot of small data transactions, Redis, even a single node of Redis, will blow away what you could possibly have imagined in terms of performance. It's ideal for caching of any kind. So I cache both data that was expensive or annoying to generate and doesn't change a lot. So if I had to work hard to get a bunch of totals for something, or to generate a nested data set for something, I would typically stick that in Redis and keep it valid for a minute or 5 minutes or something to stop us doing that on every request. I also cache things like the current headlines, again, for a minute. If a user logs in and they have the eyebrow, in the top corner, you've got their username, their avatar, a link to their profile, the number of messages they're showing. That's the same on every page, right? You've probably got templating stuff for your static front-end content. Just cache this piece, right? Calculate it once, just load it from cache every time, because the user probably will come to your site and click around for a few minutes. If you haven't used that for 5 minutes, throw it away. I use it for session data. For PHP applications, this is, in my not remotely humble opinion, a no-brainer. PHP, by default, writes sessions to the file system. Not because it's a really good idea to write sessions to the file system, but just because it's quite a safe choice. Today, not such a safe choice, because we deploy to cloud, there isn't a file system. Your stuff gets redeployed all the time. You can't write into the containers that we use today. The multiple web heads mean you have to have sticky sessions, and one node ends up madly under more load than another. Just put it somewhere all of the web heads can access it. Put it somewhere that's friendly to the cloud, Redis, especially if you're not caching enormous, great terabytes of data in your session data, and if you are, we need to talk. Then Redis is a really good choice. The other place I recommend Redis for PHP apps is if you're starting to investigate queues. If you already have Redis in your PHP stack, this will get you started. Don't go all out and deploy a really big, complicated queuing system if you are new to queuing. Throw it under Redis, see how you get on. When you outgrow it, you should be able to refactor to RabbitMQ or something. If you've used Memcache, awesome, that is a good thing, but today use Redis. Redis is incredible because it has this awareness of data types. It's more than Memcache's key value strings. It understands strings, good, we know about those. It understands hashes. So these are like PHP's associative arrays with keys and values with different names. It understands lists. These are actually linked lists, so they're in an order and you can traverse them either way. It's how the queues work. We have sets. Now, a set is like, imagine an item with tags. So you've got an unknown number of the same thing. So it's just like a series of strings, and there might be 1 or 17. Right, you're going to tag data. Sets handle that really well, and it's really good at saying, this is already in this set. Right, this is already in this set. You've got this many things in this set. Here are all the things with this tag with this. So it's very good for those sort of quick lookups. You also have sorted sets, which sounds really similar, but I use them for completely different things. The sorted sets are the same, a list of similar data types. Each one has a score. You can very easily increment or decrement this score, set it to a value. If you try and increment something that isn't set, it just sets it to 1. The data in the sorted set, it's already in memory, so, is stored already sorted. There is no sort operation. So you can fetch the head or the tail of that sorted list at the speed of light. Sort of. Very fast in computing terms. You can also have key expiry. So at key level, you can say how long this key is valid for, or give a time when it's valid until. So that's really helpful for making sure that you are tidying things up out of Redis, so it doesn't run out of memory, because bad things happen. Usually to Redis rather than the other things on the server, but either way, it's not ideal. The examples that I have here use the Redis CLI tool. If you're going to use a PHP library, or indeed any other programming language library, they all name their functions the same as the CLI commands. So this is like the vanilla version. It's very straightforward. I am going to set a key called risky feature to on. Right, so I'm going to toggle something on in my application. I want you to imagine that I type expire risky feature 3, press return and immediately type get risky feature. So I've set it, and I've set the expiry to 3. This is seconds. So if I set it and then fetch the value, it's still there. But if I type it again now, more than 3 seconds later, it's not there anymore. It's so common to do this set command followed by the expire command that we have setx that combines the two. So you have the key, the expiry, and then the value. With hashes, I use these a lot. They're like array-alike. They're relatively easy to work with. All of the commands in Redis are prefixed with the data type that you are working with. So in this case, it's a hash, so the command is h. I'm setting multiple values, so the command is m, and you know about set already. So hmset, to set multiple values into a specific hash. Now I've called the key featured : hat. The colon is just a convention. We usually use it for the namespace separator. So maybe it's a shopping site with a carousel and I've got a hat, a bag and some shoes. Featured, then you can put whatever you want in the featured hat space, and it's very easy to fetch all of the featured : star things all at once. So I've set some values: key name, value sun hat, key color, value white. Feels a bit silly in York in spring to be talking about sun hats. I guess I wrote this for a different place and time. The H keys gives me the keys, and the H vals gives me the values. And I can work with my data in that way, or I can specifically fetch an individual key if I want to. When you want to find keys, we're going to use the scan keyword. Now, Redis also has a keys keyword, which literally just returns you everything. That's ideal when you're starting out, and you'll see it in a bunch of tutorials. If you run it on a busy production system, it can lock up your system, right? So let's work with scan. Let's learn scan. I did not learn this the hard way, but I heard the stories. So let me try and pass that forward. So you can also avoid learning the hard way. So there is keys, it's super helpful, but just be really careful when you're running it. So on the first line here, I am running hset to create a hash with person : Lorna, and I'm setting the Twitter key to my Twitter nick. Then, look at that scan line. We are scanning starting from 0 And you can just do that and start getting the keys, and it gives you a cursor, so you'll get so many, and then a command that you run to get the next set. So that's why it doesn't lock up your system like keys does. I am only scanning for keys that match person colon something. So the asterisk there is a wildcard. And it returns one record, me, and then I can use the specifically hscan to scan within the hash to look for a particular value within that named hash. That's very, very useful. Let's talk a bit about queues. Every command is prefixed with the data type. It gets a bit funky in places. So L is for list and kind of for left, because R is for right when we're operating on the other end of the list. B is for blocking. It will wait until there is some data there if necessary. So we're going to push onto this list. Breakfast, newspaper. And when we start popping things back off this list, we'll get breakfast and then newspaper. So this is the world's most simple queue. If you start to think maybe I need a queue in my system, run with this. There's linked list under the hood. It'll perform perfectly well. And if that helps solve the problem that you were thinking of, then go and work out how to add an extra queuing service to your application, or how to get your ops to do it if you're still in a co-located data center. But think of Redis as a disposable data store. It is an auxiliary data store. You are never going to write data to Redis that you cannot afford to lose. It does flush to disk periodically. In my experience, it never flushes to disk when you need it to. So you should assume that at no point has Redis flushed anything you need to disk. Your code must handle the cache miss situation for Redis. Is it in Redis? No. Do whatever you need to do, put it in Redis, and you need to expect sometimes Redis will be gone. I'd recommend turning off your Redis in testing occasionally, just because it's solid as a rock and it's never going to happen, but it'd be silly if your code fell over for this. It is possible to configure how often it writes to disk, but like I say, it's a trade-off, right? Persistence and speed are inversely correlated. You're using Redis because it's fast. If you configure it so that every time you write a value to Redis, it ensures that that value has been safely written to disk before it returns successfully to you, you will experience the performance equivalent to writing your values to disk. This is basically what you're doing. Just write to a file, right? Because Redis is not helping. It also has an append-only log that you can turn on. It tries to write to the log, and then when it reboots, it brings back whatever it last flushed to disk and then replays the log, which can help a lot. But you should still expect to lose things. Listen to me. If you lose a user session, what happens? Oh no, they've got to log in again, right? It's not the end of the world. If people put transactions through and then you lost that data, that is the end of the world. Don't put that in Redis, right? And that's what it's for. It's there to help you crutch against doing the same thing repeatedly, but you need to be able to manage without it, and that's where you'll get the best value out of Redis. I've talked mostly about single node. Replication is simple. Clustering is now built in. It used to require an external tool, but that is not true anymore. The sorted sets that I mentioned are incredible. I've linked to did I link to a blog post? Should have linked to a blog post. I'll tweet it. Showing how to use that for things like, you know, when you're viewing a hotel site and it's like, 3 people have viewed this today. That's all. Somebody views the page, increment the value in Redis, and you can fetch it back really easily. It's brilliant for those leaderboard type things with the sorted sets. I mentioned the queues. It also has PubSub built in. I was going to have a slide about it, but it fits online, so it's here. Here is how you do it. The thing that wants to hear about events, all the things, should subscribe to a channel name, and the thing that is publishing those events should publish to the channel name, whatever the message is. You have PubSub. Hooray. Documentation is awesome and has a good sense of humour, which I like. You may also enjoy this free reference card from DZone. I wrote it, so clearly it's fabulous. For working with PHP, I tend to use the Composer pRedis library, which is entirely userland. You don't need any extensions. If you find that you are having some performance problems, there are extensions around, and you can add PHP iRedis to your pRedis composer, which will just speed up the transactions to the server. The joy is that you don't need an extension, and I find it works pretty well without for most platforms. Guess what? We have a hosted version on IBM Cloud. We rebranded the cloud from Bluemix. Listen to me, IBM Cloud. Yeah. Hopefully you knew IBM has cloud. If not, well, I've done my job already and the rest is decoration. Okay, so let's talk about CouchDB. I was very clear about Redis being an add-on to your existing stack. If you don't already have Redis, you're going to add it on. Postgres is, we're going to replace MySQL or whatever you're using as a backend with Postgres. CouchDB is something slightly different. Could be a main database. I work quite a lot with CouchDB. It's called Clouded on the IBM Cloud. Cool startup does hosted CouchDB, which means that I work with a bunch of CouchDB contributors, which is fabulous because they're very excellent humans. CouchDB could be your main database for the right application. It's, I often see it used by particularly startups who aren't quite sure what they're doing yet because of the pain of making schema changes on a relational database. I also see it commonly in product databases, and especially where an application is a bit more componentized. You see CouchDB as the data store for individual components where the document databases make sense. So let's talk about when document databases might make sense. Apache CouchDB, there's a theme here. It's an amazing open source data store, just like all the others. Its acronym I don't think they really use this anymore, but the acronym originally stood for Cluster of Unreliable Commodity Hardware. Meaning, hard disks will fail, this fell off the back of a lorry, we're in a variety of different data centers and sometimes things go wrong on the internet. Right? CouchDB is written in Erlang and is kind of just up for that sort of a world. It's also, for a web developer, built with familiar things. It has an HTTP interface. Now, it's not that I think you should talk to your database with curl. Don't laugh, I enjoy it. Right. But what it does mean is that any programming language that you use, which has the ability to make web requests, can successfully connect to this database. It is a RESTful interface. We already know how to work these. There is no, oh, my document database provider changed their binary protocol and then didn't release the drivers for my programming language, right? It's never going to happen to you. If you can make an HTTP request, you can use this database and they can't lock you out. It also means that things like authentication, metadata, compression, this stuff's been solved for HTTP. It's made of the web. And so it fits really well for us. There's a very friendly web front end. It is called Photon. And it is called Photon because the previous version of the web interface was called Futon, because the product is called CouchDB and we let geeks name things. I feel like I ought to apologise, so I'm not going to. It's familiar. You work with CouchDB, you're working with JSON objects, you write the views in JavaScript, you're PHP devs. I'm just going to gamble and say maybe some of you know some JavaScript, right? So it's something that's very easy for us to work with. It's a NoSQL database, and with PHP, you can just use Guzzle. I'm currently working on a PHP CouchDB library that sort of wraps Guzzle because I was writing the same Guzzle all over the place in my applications. So we do have some libraries, but you're not locked into those. If you don't like it, you've got options. Let's talk a little bit about document databases, because they can be a weird and interesting situation. This is intended to be a picture of a document database. Instead of rows, each piece of data is a document. And it encapsulates everything that's related to this. We don't really join document databases, we just nest the data. It is a denormalization party. So every record can look different, but if you look at these records, there's some similar stuff in those, right? When you are very experienced with relational databases, and I'm including myself here, when you first start working with document databases, you're like, every record can be different. Are you crazy? Right? This is chaos. Who would do that? Spoiler. When you work with a document database, the same piece of code writes the records and reads the records. They really look very similar to each other, right? Every record is not completely different from every other record, but it's brilliant for changing fields a bit and maybe doing a batch job to update the old records because it doesn't lock your database, you're only operating one document at a time. It's excellent for sparse attributes. Perhaps you've seen something like Magento, which uses the EAV pattern on the back end to get around the fact that some products come in colours, some come in width and height, others come by horsepower or milliwatt hour. Like, well, you've all load of empty columns there, and it gets a bit nonsense. This is ideal because you just put in the fields that you need. It's also perfect for things like content management systems, where you might have an image block, a header block, a link block, a carousel. You can have code that says, oh, it's one of those. Handle it like this. And each one looks different. Document databases are ideal, and I see it in that situation a lot. I want to show you around the nitty-gritty, just because I think this is less likely to be familiar to you. And yes, I'm using curl for my examples. I have a blog post about, it's called HTTP tools, but it's like, ways we all talk to CouchDB. So have a look, because there are lots of alternatives. It's a RESTful interface. So when I create a record, I am going to put it to the URL where I want the record to exist. All I'm doing here is sending some data to say, this is the JSON data, this becomes the document. And the result comes back. I could also use a post verb here and not specify the ID. That's pretty common, but if you do that, your examples don't fit on your slide. So, because the IDs are longer than 1, 2, 3, 4, just saying. I do use curl because it's present on every system. But if you've used like Postman, or I think the PHP Storm stuff has built-in HTTP query stuff, go for it. Just whatever tools you're using, and that's the joy of this. You use your tools. We're using a standard called HTTP that you might have heard of. I write a document, it's got an ID. Hooray. When I come to update this document, I need to supply the ID and the new data. I also need to supply which revision I'm updating. This is RESTful, it's not an atomic update. I need to fetch the existing row, alter the data whatever way I want, and put the new data back again. In the meantime, you might have put a new update, and I don't want to overwrite yours. So the way that CouchDB deals with this is when you fetch it, you get the ID and some revision information and the document. When you update, you must supply that revision information, and then we can tell if you're out of date. If you are, you'll get a 409 conflict response, and you'll have to try again. This is the root of how CouchDB keeps track of what's changing on its database, but also about to talk about the replication process and how it can keep multiple databases in sync. And this stuff is really important because it can handle edits on multiple disconnected database nodes and successfully resolve those. And you need the version information to make that work. CouchDB has a changes API. Now, can you think of any situation where it would be useful to receive an event when there's a change in your database? Something happens, some code might react to a change. Yeah. CouchDB has this built in. So you just subscribe and say, let me know about the changes, and you can get them coming over a connection. Or just pop in every now and again and be like, hey, what changed? And it'll let you know. So you just say, I want the next set of changes, and they come down. This is the basis of CouchDB's replication ability. It has the best replication I have ever seen. In the PHP community, you may have seen it, the Drupal workspaces feature uses CouchDB's protocol. You can use CouchDB, but you don't have to replicate data from one place to another. Because don't write your own sync protocol. I mean, for fun, but then deploy this one. because it's been very well thought through. You have a CouchDB. Let's say I would like to do some work on a CouchDB that's one of our open data CouchDB databases. So all I do is I replicate that down to my local CouchDB and then I work on it. It's like a database backup. It's in fact how we do backups. If I've made some changes and I'd like those to go back, I can replicate in the other direction. I can also have 2 or 200 databases all keep in sync with each other. So clients can all connect to any one of those nodes, and it can two-way sync, or 200-way sync, between all of those other databases. And it can do that ongoingly. If for some reason we drill through the transatlantic cable, imagine there's only one and no satellites, right? We disconnect 2 of our database nodes, users in different locations use whichever database they can reach. It's a terrible problem. We have to unroll cable by hand across the Atlantic, it takes a while. A week later, we reconnect those databases, but users have edited their records on both sides. CouchDB doesn't care, it'll replicate. If you've edited the record in both places, you get a conflict. But what it does is it looks at those 2 documents and says, this one's the winner. This becomes the new record. This one is stored, you can refer to it. If you have a user interface, you can offer it to a user as an autosave. The algorithm for choosing that is deterministic, meaning it always picks the same one. So as this same conflict propagates around all your databases, it always just picks the same winner. The losing document is available within the old document, so you can have a look and offer it to the user. I have literally never seen that implemented. CouchDB picks the right winner, I'm generalizing, but in general, really does seem to pick the right document. And unlike a Git conflict, it doesn't say, I need a human. Because if you're replicating big data, we haven't got time for this. So it picks a winner and it's right most of the time. So that works pretty well. The other data is crucially not lost. So if that's not correct for your use case, you can fix it. It's very safe. Might be a bit early in the morning for this. It's one of my favourite things about CouchDB, so I'm going to tell you anyway because they gave me the stage. CouchDB views. When you work with a document database, essentially you write to the database and you fetch everything and that's kind of it. If that's not the question that you want to ask your database, if you want to be able to get it to do some aggregation or filter those results for you, you're going to use a view. Now, CouchDB uses MapReduce. It is intended to be a distributed NoSQL database. It is very, very good at big data. I think this isn't the only way to get data out. We also have something called Mango, which is intended to be like the Mongo query language. See earlier remarks about geeks and naming things. I am sadly not in charge, or this stuff would not happen. It's also not that much like Mongo's query language. It's like someone sort of talked about it a few years ago and then decided to, Anyway, if you know any MongoDB, don't think Mango is anything you know. If you don't, then it doesn't matter, does it? Okay, so the views are very performant, and it's typically how I work with my CouchDBs, and they use MapReduce. So just on the off chance that you're not totally up with all your computer science algorithms, let's talk about MapReduce. MapReduce is made of 2 steps. There is the map step and the reduce step. They're actually both quite simple. I think people try and make it sound harder than it is. When we do the map step, we walk through every document and we say, right, what's going on here? Should this document be in my view? And what am I going to look it up by? What keys should I init? If you're not running this on your laptop and you are running it somewhere else and there is a lot of compute available, each document is independent. This scales horizontally for as big as the compute that you want to throw at it. This is why people handle big data with MapReduce. Right, it scales brilliantly. If all we want to do is filter, then we only need the map step, because we can now fetch things by the key that we emitted. Let's try and walk through an example. My JSON got really small in the example, so here it is big before I shrink it, and I'm looking at just a products database. The product has a name, it has an array of departments, it has an in-stock Boolean, and it has a added date time field. So, we've got the JSON. This is a CouchDB view. This is the map step. It's written in JavaScript. It's a JavaScript function that takes the argument doc, which is the document you are dealing with, and calls the function emit. with a key of your choice. All I'm doing is emitting the name. This view is going to allow me to look up products by name. Notice that I'm not emitting any values because I'm just going to look up a whole document by name. I'm not going to use the values. CouchDB knows which document this key was emitted from and can therefore fetch me the document when I'm fetching the view. This is also how CouchDB maintains its views. We're not doing this on every query. It is stored, manifested. It knows which document it came from. If you change the document, it reruns the map step just for that document. You insert a new document, we rerun the map step just for that document. It's much, much more performant than trying to run queries from scratch every time, as you have to on other platforms. So this example, we just emitted one value for every product. How about conditionally emitting values? We don't want all of these products to be in our view. How about products that are only in stock? Okay, well then do an if and either emit or don't emit. If you don't emit, the document's not in your view, that's cool. How about we want to emit loads of times? I want to count how many products are in each category, but there might be multiple category departments. There might be multiple departments, so how many outdoor items do I have? How many clothing items do I have? How many children's items do I have? If there's something that's in all of those, then we need to emit once for each department. And that's what this does. It iterates over the tags and emits as many times as we find tags. Therefore, I can look up all of the outdoor items very easily, for example. Let's talk about the reduce step. We do the map. We've output a bunch of keys. We collect the same keys together. So that question about how many products are in each department, that's an aggregate function. I'm not returning I'm starting with a list of products, but the result is not a list of products. Right? The in-stock example, that's a list of in-stock products. But the answer to the question, how many outdoor products do I have, that's an aggregate function. You were doing that in SQL, you would need a group by. Therefore, when you do it in MapReduce, you need a reduce. So we take everything with the same key and we put them in the same bucket, right? We'll put all the outdoor ones over here, we'll put all the clothing ones over here. And then I'm going to count. So we give one bucket to each piece of compute and we say, right, you count these, you count these, you count these. We get to the result really quickly. That's the reduce step. You can write your own function in JavaScript for reduce, but you are probably doing it wrong. Sorry. We have built-in count, sum, and something called stats, which does average and standard deviation and things. And that covers 99% of what you're likely to do with this. So you sometimes only need the map if you're filtering the documents, but if you are aggregating the documents, you need the reduce as well. I just want to talk about multiple keys, because this is where it gets magical. I've got a view that outputs the department and the product type as two keys. When I get the results back, and it's counting them, so it's showing me how many, in the men's department, I have one t-shirt, the women's department I have 3 bags, 1 pair of shoes, etc. And I've got it keyed, so I keyed with an array on department and product type. How about if I'm only interested in department? Do I need a new view? No. So this group equals true. Just say how many levels of group you want. Group level 1 just gives me the top level. So you can make your key as detailed as you want, and then get the output of the reduce at whatever level you want. So for example, I often see sensor data keyed on year, month, day, hour, minute, second. And now you can aggregate over whatever unit you want off a single view, which is already manifested. This thing performs like something I never expected. CouchDB, it's an Apache project, it's open source, they're super friendly. It's written in Erlang, which is easier than you'd think. There's some very good documentation online. The Apache CouchDB O'Reilly book is actually an online thing that you can contribute to and read, or just get the book, also works. I don't have it in this talk, but there's also a JavaScript library which is compatible with CouchDB. Geeks naming things. It's called PouchDB. I am seeing quite a lot of progressive web apps using CouchDB in the browser, because if you are connected, then it's able to sync with that excellent replication that I mentioned back to CouchDB. That is a separate talk. We'll be here all day if I follow all my tangents, but that's my top tip. I mentioned that I'm working on a PHP CouchDB library. This is pretty alpha, but I've had pull requests from a bunch of people that I don't know, which is great. And I think I'm seeing CouchDB is just very web-friendly, being used a lot by the progressive web apps that I mentioned. It's something which it's not a new product. It's not even that trendy, but I'm definitely seeing it used more with PHP. So I think that's why the library is being picked up. I would really appreciate feedback, issues, patches, but issues would also be fine. And let me know how you're experiencing that, what you think. Guess what? There's a hosted version on IBM Cloud. It's called Cloudant on the IBM Cloud, so you need to work hard to find it. Like I say, I work with some absolute experts in that space, and I find it a lot of fun, actually. I've always liked databases. I'm normally not fussy, but for document databases, this is one of my favourites. So, conscious that I'm between you and coffee, I will try and wrap up a bit. I've tried to cover here a few different things and give you some ideas of where they might fit in your own stack. I picked 3 specific products, but I don't want to preach too hard on the specifics. With Postgres, like I say, a bunch of those features are coming to MySQL. If you're using SQL Server or Oracle, a lot of this stuff is still valid. Redis, there isn't anything else in that space. It's just use Redis. It's awesome. It's actively developed, and it's very, very good. In the document database space, you've probably heard about MongoDB. CouchDB is in there. Rethink is not widely used, but also Elasticsearch is a type of document database, so you may well have that in your stack as well. If you come to this talk, see all this stuff, and go home confident that you're doing the right thing, that's okay as well. I want you to have this opportunity to learn more about things that you maybe don't have time to play with, but once you're informed, you know a bit more about it. That's all I need. That's all I'm interested in. Okay, so a few resources for you then. Here's the link to the joined in feedback, or just it's top of the front page today on join.in. Joined in is vitally important. Otherwise, you and other audiences like you have to listen to the same old nonsense year after year. So please offer feedback to your speakers. Things that did work, something you'd change, right? Be constructive, because those speakers will listen and you'll have a better experience at future conferences. The slides, if you want them, are online. Help yourself. If you are interested in learning more about databases, I cannot recommend this book, 7 Databases in 7 Weeks, strongly enough. It covers the databases that I mentioned today, plus a bunch of others. I think there's some graph database stuff in there, and I think some columnar stores. So if you're interested, have that. And absolutely chat to me through the day. Top tip, don't wait for me to stop talking, because you'll wait a long time. Please come and chat to me about anything that you're interested in. I am here all day. I'm happy to take questions on Twitter or whatever. I don't really have time for questions now, so go and get your coffee, but come and chat if you want to. And really enjoy your day at PHP Yorkshire. Thanks a lot.